the workpiece that we are going to machine here today is this, which is liquid based cold plate, and this is a vertical machining center which we are going to mount it on. This is a CNC machine, and this is a carriage on which we have mounted the workpiece. And in this we have a turret here, and these are all the tool station, different tool station. This is the tool which we are going to machine the workpiece in. Not going to stop it. So usually the machines comes in this format, and it will be closed. We cannot actually see the machining with a normal camera. So we should not usually override the safety features to see the machining. So but for the sake of this dry run, we have opened this window here. Now as you can see, the bed is moving towards the right hand side. If you see the markings there, where we have the coordinate system, which is X, Y and Z, where X is minus on the right hand side. Why is this? Because in the conventional machining or drawing features, we take origin as this, and X axis plus X will be on the right hand side. But since the bed or the carriage is moving towards the right hand side, X or this point will be going towards the plus of this workpiece. So that is why it is pointed as minus X and minus Y on the other side. So these are the different tool station as I showed, and this is the carriage. This has a this machine also has a coolant system, water jet. There are 3 different water jet coolants. In the machining, while machining, that will be on. So just for this safety, that we have not turned it on now, since we are doing a dry run. This is the homing operation, where wherever the workbed is or the tool station is, first the tool will move in the safety from the position to the safety position. That will be the home position of the tool. From wherever the Z value is, it will move to the 0, and wherever the bed or the workstation is, that will move to the home position. X, Y and Z are 0 at this position. So now we are making a water channel for this. So as you can see, we are only showing the dry runs here, since the normal machining has to be with the safety precautions of coolant and feed. We are not giving any feed, or we are not switching on the coolant here. So we are only making a dry run for this water channel making. So now the spindle is on according to the code which is fed to the machine. And it is taking the path which is given as per the Cartesian coordinates format. In the conventional milling machine, we can move the workpiece towards the tool station, but in here the tool also moves towards the workbed. But in both the cases, workpiece will only take the X and Y directions. In here, the Z direction is taken care by the tool. Now as you can see, we are trying to achieve here the two triangle finish, but we are only showing it in dry run. So as you can see, it is we are doing a dry run here. So for the given material, we cannot actually change the feed as well as the cutting speed. It purely depends on the material property of the workpiece. which we are going to machine. So this is a human machine interface where we can input all the data which are G codes and M codes, which are understandable by the machine, and we also input the offset values in the offset panel, window here. So once we take the X, Y and Z offsets, we go to the offset window and we measure X and Y to make the offset as 0.0, for X and Y, and we manually input the Z value, which is shown in the Z position, which is the machine Z value. This is the work offset which is inputted for this value, G54. G54 is the standard G code where we are taking the offset value for. So where we input X0 and Y0, and we'll press measure, and it will take the values where the tool exactly positioned at. This will be the X0 and Y0 for this workpiece now. So as you can see now, the program has been fed to the human machine interface here, and we'll be running this G code and M codes in auto or single auto mode, where single auto refers to one line at a time, and auto refers to the whole block at once. So in single auto we have to keep pressing for each and every line for the machining, but in the auto mode all the operation happens at once, the one block, and then the machine stops for the next input.
Hello, I'd like to now point out to you how liquid cooling takes place in the case of high power equipment. It is counterintuitive, but liquid cooling is actually quite good and better. But the thing is, maybe around 2 to 5 kilowatt. After that 5 kilowatt thing, it sort of becomes compulsory, because you can have compact systems, and the heat cooling part, or sending away the heat to the ambient, can be handled separately. Hence, we end up with some sort of fluid, and unlike forced air circulation, liquid has some advantages. So you see here, this is a sand casting. After it comes from the the green mold process, we need to finish it on all the directions. Do we really need to finish it? Yes, because finally when this goes for pressure die casting, they will have a reference, including where to start the machining and which is critical and which is not critical. So you have here a cavity on the other side. Then you see here, this one is a motor feed. If you want smooth surfaces, you require to fit the motor feed. So you have here a cutter, and this cutter, you need to keep changing the cutter. And then you see here, the surface finish is not very good. And then you see here, you see on these points, all these points, a lot of air pockets have been there. Right now, it does not affect us really, because it is outside, and in case of the thing, it is a problem. But still, we have a beautiful surface here. So you have all these cutter, this is an end mill, and actually it's a shell end mill. It is both a side and face cutter type of thing. Okay. So you see here, we have chips here, we have everything here, and then most important here is, how do you clamp the device, how do you run the machine. This clamping and all is very critical. Even a small vibration in it completely destroys the whole finish of it. In production, if the units are maybe up to a few hundreds, and individual batch numbers are very, very small, saying at a 10 and so on and all that, you have no choice but to go for this gravity casting. Slightly improved versions are there now, by which you can get a slightly better finish depending on the type of mold you make. Sometimes it is possible for us to use our first job itself for digitizing the final operation. So, you take this first sample and then put it in a digitizer, it scans all the surfaces. Usually there will be a small ball like thing, and this whole thing can be directly converted into a 3D model. Once the 3D model is made, repeating it will be very, very easy. Next sand casting, what we get, we just need to put it in a CNC machine, and if you start with some one reference corner and 4 other corners, then the whole machine, we can program it such that somebody need not sit here and keep on adjusting it, and dimensions are reasonably guaranteed. So, thank you. From here now we will go on to the actual application of where the thing is used. Hello. So, this is typically a power electronics setup. You see here that our students have been trying various drive circuits, and at the bottom of it, this is probably one of those switches which form part of the minimum 6 you require whenever you want to make a 3-phase inverter. Okay. So, you have a switch here, and you see you have these heat sinks and all that, but this is only a simple experimental setup. When you are talking about a 100 kilowatt drive, even if you talk about a 90% efficiency, you still end up with 10 kilowatt loss. It may be transient, but then how do you get rid of those large numbers like that? That is where we now come to this water cooling. This is what you wrongly call a automobile radiator. It does not radiate, it is just a heat exchanger. From a liquid surface, we have these 2 pipes. What you need to observe very well is that there are small parallel tubes here. Typically, to keep the cost low, they are aluminum tubes, and also they are finned and they are closely spaced. And these 2 important things, what you like to see is, this is called the top collecting header, this is the feeder header. This header feeds the water here, and then this header, it's somewhat diagonally located. In general, in the simple device, there is no elaborate other thing, the tubes can be bent like this. And then you see here, very, very important thing is, already as part of this whole thing, this fan is fixed. So, the advantage of this is, if you go to the manufacturer's catalog, they will give you information about what is the rate of water flow. With given rate of water flow, how much of heat it can dissipate depending on the ambient and so on. That Q, these are catalog information. This one is approximately square, because if you see, that fan is a circular thing. This is optimized very well. But if you see the one in a practical car, you will notice that it is thin and long. The air conditioning things are usually thin and long placed between this. Now, let me come to the actual power devices. This is the actual switch. So, you see a combination of, you have seen these things, this is a practical switch. So, at the bottom something else is there, I will come back to it. And this switch, if you go back to the electrical schematic, requires first of all a DC link. This represents a DC link. This DC link comes here and ends up in the huge capacitor here. Okay, right now, because of our practical considerations, they have just put it here. Eventually, this will end up with proper connectors here. And the critical part of this is what I wanted to take a look at it. Please have a look at it here. You have seen this. These are all thin channels like thing. And this is sitting on top of this, and directly these things align themselves here. This whole thing is a little like the other devices there. What you'll notice here is there's a air inlet, a water inlet here. The water seems to come here. Okay, after this you have various types of grooves here, and then you see here this one directly sits there inside. Moment it sits here, this whole assembly is the corresponding heat exchanger where the heat is picked up one. This heat exchanger has, this is where I thought I'll point out to you. You see this grooves, this will go and sit here, and it ensures that the water that comes here neatly goes here, and after that it goes here, back here, and it goes back like this. So you have a path like this. The combination of this and this forms the same function as the header that you have here. Once it is sitting neatly in place, you will see that everything is taken care of, and you get the 3-phase output here directly. And this is the printed circuit board which has been designed such that it can sit on top of it. You see here we have extremely well laid out, beautiful, highly densely packed printed circuit boards which have been made exclusively for this purpose. You see here, you see that this is our design, and then even this printed circuit boards, if you see carefully, there is some reference plane. Right now I will not venture to call it anything. I will not call it a ground plane or anything, but there is a reference plane here, and this other thing has all the other populated components at this. Probably this is a populated board, and this is the original from which it has started. And boards like this, it's possible, see other side, there is some other operation is possible. I'll leave it here. Now I'll take you to the you see this cover, and very important thing to notice for you is there is a beautiful gasket here. The advantage of this is the moment you close it fully, and this looks a lot like a automobile gearbox or something. Here also you have a large number of these screws and all that, and then and the usual all these precautions are there. I'll just leave it to you here. And then inside, this lecture is not about the power electronics or anything. This lecture is about that there are one portion of this which is the where the heat is exchanged from these devices through I will loosely use the word cold plate. This again, if I remove it a little here, this is probably, you have no other choice but to make it out of injection molding. It's a non-ferrous high pressure injection molding. Then there is a gasket here, and this gasket goes and sits here, and once the whole thing sits inside, this forms that part of it where the heat is picked up, the heat exchanger where the heat from the hot devices is picked up. Next you have this water cooling, the water channel here, and afterwards you have the corresponding heat exchanger where heat is exchanged to the ambient. And the moment you seal it, and then you see here this comes with special type of connectors which I feel are equally important here. You see here, some of these are sort of industry norms. Norm means saying it is not compulsory or anything, everybody follows similar norms so that whole thing can be directly made into compatible devices. So corresponding thing for this is this. You see here we have a beautiful connector here, and then only things that are required for purposes of study have all been there. This is a shell connector, and then I don't know whether it is meant for it. I will not risk putting it and taking a chance, but still let me just put it close enough and see whether it mates and so on here. Very rarely they use it. This also has a corresponding one more another cable relief channel and all that. Usually there will be only a few cables here, water, and then this is the control line, and with this we are ready. And then you see here this capacitors and all already come here as it is. They all come with marking. And there the PCB means something else. It doesn't mean our printed circuit board. It means some other hazardous, it is a ROHS compliant device, so it doesn't have those hazardous chemicals inside. And then one more time, permit me to gently lift it and show you the other side. Now can you see here, we have a small add-on here. We can remove this plastic piece, and then after that we have access to these connectors and all this side. Okay. Similarly, if you see this here, this is a cavity, and then there is water which comes here, which takes a form here, and these things are all made for this. That is exactly what you have been seeing there. Now, after we go there down, our manufacturing engineer, he will now see how well, whether we can create all these small channels and this. Mostly we are not attempting this, it's too complicated for us. We will not be attempting any of these things here. So I just wanted to show you the various types of operations and things here. Okay. So thank you.